Hey, this is Presh Talwalkar. What is the value of the following infinite series? S is equal to 1 squared over 2 to the power of 1 plus 2 squared over 2 to the power of 2 plus 3 squared over 2 to the power of 3 plus 4 squared over 2 to the power of 4 and so on, where the general term is n squared over 2 to the power of n. What is the value of S? Pause the video if you'd like to give this problem a try. And when you're ready, keep watching to learn how to solve this problem. The first thing we'll do is we'll check for convergence of this series so that we know it's a convergent series. Then we can do the normal manipulation we do, like multiplying and subtracting series from each other. We won't run into any problems where we're subtracting infinity from infinity. So we will use the ratio test. We take the limit as n goes to infinity of the absolute value of the ratio of consecutive terms. We substitute in, and now we're going to simplify. So this works out to be 1/2 multiplied by the square of n plus 1 over n. We then simplify the fraction, and then simplify the limit. So this is equal to 1/2 times 1 squared, which equals 1/2, which is less than 1. So we have a convergent series. The first method we'll use to solve the problem is to find a pattern. We have this sum. Now let's just write each of the square terms out. Now let's multiply this entire series by 2, term by term. We can do this because we know we have a convergent series. Now let's line up the denominators. We'll subtract the top equation from the second equation, term by term. So we have 2s minus s, which is equal to s, and this is equal to 1 plus 3 over 2 plus 5 over 4 plus 7 over 8 plus 9 over 16, and so on. Now we will subtract 1 from this series, and then again we will multiply by 2. We will take this series and we will subtract it from the one that's right above it. So we have 2 of s minus 1 minus s is equal to 2 plus 2 over 2 plus 2 over 4 plus 2 over 8 plus 2 over 32 and so on. So this simplifies that s minus 2 is equal to 2 plus 1 plus 1/2 plus 1 over 4 plus 1 over 8 and so on. And now we have something that we can solve very easily. 1 plus 1/2 plus 1 over 4 plus 1 over 8 and so on is a standard geometric series with a common ratio of 1/2 and a first term of 1. So s minus 2 is equal to 2 plus 1 over 1 minus 1/2, and that equals 2 plus 2. This means s is equal to 6, and that's one way to solve the problem. Now another way is to consider sequences. So we have this term Sn. We'll look at the sum up to the nth term. We can write this in summation form, that this is the sum from n equals 1 to infinity of n squared over 2 to the power of n. Now we can re-index this going from n equals 0 if we have n plus 1 squared over 2 to the power of n plus 1. Now since n equals 0 will be a term that's equal to 0, we can also re-index this from n equals 0 to infinity of n squared over 2 to the power of n. These are all just different ways of writing the same sum. Now from here, we're going to take this summation minus this summation. In fact, we will take 2 times the blue summation. So the sum is equal to 2 times the blue summation minus the green summation. That's of course equal to the original summation. So now we have 2 times the blue summation minus the green summation. So let's simplify this. The 2 will cancel out in the denominator. So now we have 2 to the power of n in both denominators. We can group the summation, and then we have a common denominator, so we group this all together in one fraction. We can now simplify the numerator. We expand the binomial, and then cancel out the n squared terms. So we have the sum from n equals 0 to infinity of 2n plus 1 all over 2 to the power of n. We split this apart, and then we will split this apart into 2 different summations. So we have 2 times the sum from n equals 0 to infinity of n over 2 to the n plus the sum of 1 over 2 to the n from n equals 0 to infinity. Now the second summation is easy to recognize. This is the sum of a geometric series with a common ratio of 1/2 and a first term of 1. So this is equal to 1 divided by 1 minus 1/2, which is equal to 2. Now what about the other summation, n over 2 to the power of n? This is an arithmetico-geometric series. So here's how it's written out. 1 over 2 plus 2 over 4 plus 3 over 8 plus 4 over 16 and so on. So here's one way that we can solve this. We know we have one term of 1/2. We then have 2 terms of 1 over 4 and we'll stack them on top of each other. We then have 3 terms of 1 over 8, which will stack on top of each other. Then we have 4 terms of 1 over 16. So we're going to continue this pattern, and we're going to create like a triangular shape. The very first line is a geometric series, starting with 1/2 and a common ratio of 1 over 4. So we know this is equal to 1. The second is a geometric series that starts at 1 over 4, or it's the first line minus 1/2. Either way, you can get it's equal to 1 over 2. The next one, we subtract 1 over 4, or we have a geometric series starting with 1 over 8. So this is equal to 1 over 4. Then we subtract 1 over 8 to get 1 over 8. So we can see each of these lines is a geometric series. And in the end, if we sum all these together, we're going to end up with another geometric series. We have 1 plus 1/2 plus 1 over 4 plus 1 over 8 and so on. So the sum of all of these is equal to 2. We now substitute in. So s is equal to 2 multiplied by 2 plus 2, and that gives us the answer of 6. So now here's a third way to solve it using a generating function. Suppose the absolute value of x is less than 1, and say f of x is equal to 1 plus x squared plus x cubed, and so on. We have a geometric series with a first term of 1 and a common ratio of x. So this sum is equal to 1 divided by 1 minus x. Now let's differentiate term by term. 1 becomes 0, x becomes 1, x squared becomes 2x, x cubed becomes 3x squared, and so on. So then we can differentiate 1 divided by 1 minus x, and that's equal to 1 divided by the square of 1 minus x. We will multiply both sides of this equation by x. Then we are going to take the derivative of this. So we differentiate term by term, so we get 1 plus 4x plus 9x squared, and so on. Then we have to differentiate x divided by the square of 1 minus x, so we use the quotient rule. We simplify this, so we get the derivative is equal to 1 plus x divided by the cube of 1 minus x. We're almost there. Let's take this entire series and multiply it by x. So we have x plus 4x squared plus 9x cubed, and so on, and that's equal to x multiplied by 1 plus x all over the cube of 1 minus x. We just substitute x is equal to 1/2, and that exactly gives us the series s that we want. So we substitute on the right-hand side, and we just need to simplify this, so we get that s is equal to 6. And that's a final way to solve this question. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.